this question, at t equal to 0, a unit step is applied in the input voltage. Now since the op amp is linear, we get 0 volt on the negative terminal. So what we get is 1 volt here. After the unit step we get 1 volt here, and it's been 0 volt here. So therefore it's 1 milliamp flowing into the across the resistor, through the resistor. But this 1 milliamp current cannot flow into the op amp, as the op amp is ideal. So therefore it flows into the capacitors, right, linearly charging them up. Initially the voltage across the capacitors are all 0, the output voltage is 0, so the voltage is 0 here, right? So the idea is that for as long as the voltage across the Zener diode is less than its threshold, its Zener voltage, we will get that the capacitor is the Zener diode is non-conducting. So you can assume for now that it's not there. If the Zener diode is not there, then you will get that the capacitors are in series and are equivalent to a 0.5 microfarad capacitor, right? 1 microfarads in series. So 1 milliamp flowing across them. So 1 milliamp flowing across them, C delta V by delta T is equal to I, right? So since we are assuming both of them are in series, V minus is one side and V out is the other. So since current is flowing in this direction, we get that it is delta V minus minus V out divided by delta T. C times delta V by delta T is equal to 1 milliamp, and we get this expression between delta V out and delta T for until the Zener diode is non-conducting, right? And of course by the voltage divider of the two capacitors, we will get that V Zener is V minus minus V out by 2, right? This is V Zener, so delta V Zener will just be the same, right? And bringing the delta inside, you will find that since this is not changing, this is constant, all you will get is minus delta V out by 2. So that is delta V Zener. Thus the Zener diode reverse voltage, right, initially at 0 volt crosses 2.5 volt after t equal to 0 at the following time t, which we need to find out using this expression, right? So substituting V Zener is 2.5, right, we get that t is 2.5 milliseconds. And of course this expression was obtained by substituting for V out into this expression here. So after 2.5 milliseconds, you will find that the Zener diode takes all. So V Zener is 2.5, it comes from the problem itself, yeah. So after the Zener diode becomes conducting, it will take all the current. So you have the Zener diode in parallel with the capacitor 1 microfarad in series with the other capacitor 1 microfarad. But after the Zener diode becomes conducting, right, it will just maintain this voltage as 2.5 volt and it will take all the current, right? So you can just ignore the other capacitor, right? But the current that flows is still 1 milliamp, right? And so now in this circuit, if we ignore this capacitor, right, and the current flowing is still 1 milliamp, right, and this is now at we need to find out how much time it will take for the output to cross minus 10 volt, right? So the idea is that so it's now a 1 microfarad capacitor, right? So V out is equal to minus 5 volt. So how do we get this? So the delta T in this expression is 2.5. So delta V out, we get delta V. So we get delta V out is equal to minus 5 volt by substituting that there. And since V out started at 0, delta V out must just means how much V out has changed. So the value of V out at t equal to 2.5 milliseconds is minus 5 volt, right? Thus the top 1 microfarad capacitor is charged to so the top 1 microfarad capacitor has V minus on one side, right, and this is minus 5 volt here, which is V out, right, and the Zener diode is 2.5 volt. So this is minus 2.5 volt, this is 0, so the capacitor, so with plus minus polarity here, is 2.5 volt. We want the output voltage to be minus 10 volt. So the idea is we want this to be minus 10. The Zener diode voltage doesn't change, so therefore the idea here is minus 10 plus 2.5, this is minus 7.5. So what we want is that the top capacitor should charge up to 7.5 volt with that polarity. So the charging current is still 1 milliamp, right? So the capacitor starts at 2.5 volt and it must charge up linearly to 7.5 volt, right? So it must have a delta V of 5 volt. Thus our delta V is 5 volt and a capacitor is charging up, a 1 microfarad capacitor is charging up linearly with 1 milliamp current with a delta V of 5 volt. So therefore we get that C delta V by delta T is equal to I, which means delta T must be equal to C delta V by I. So that is what this formula is here. This is C, this is delta V, this is I, right? And substituting there appropriately, we will find that delta T is equal to 5 milliseconds. Now since we started at 2.5 milliseconds and delta T is equal to 5 milliseconds, it means we have to add these two up, right? And we end up at 7.5 milliseconds. Thus the correct answer is C, 7.5 milliseconds.